Hey guys, Sophie Line here. Welcome back or welcome to my channel, whichever one it is. But we're here at the amazing Pima Air and Space Museum in Tucson, Arizona. And early at the beginning of the summer, I was like, we're going to do a set of videos. We're going to have our kind of aviation adventures. And I asked for some audience participation and what you guys wanted to see. So I went ahead and asked, what do you guys want to see from the aviation adventure series, sort of the summer of aviation here at Pima Air and Space? And far and away, the most popular response was the SR-71. But I want to show you a little bit of something different today, and so we're going to focus on the start cart and the drone behind me, and I'll turn the camera over to Mr. Marchand, director here at Pima Air and Space, to share a little bit about this program and its history.
All right, so we're standing in front of an unlikely pair, and truth be told, these two don't really fit together as much as people think they do. The aircraft above it is the SR-71, which was the ultimate evolution of sort of the Oxcart program aircraft. But the genesis of the SR was really kind of inverted, right? The program, the Oxcart program was initially intended to be the carrier for this little baby here. So this is known as the D-21 drone. It doesn't have a nickname, but in sort of an encapsulated nutshell, and I'm going to put a qualification up here for this video, is I'm going to talk more in generalities because there's so much granular detail with this thing, and there's so much been studied about and so much written about it, and there's so much passion around it. I really don't want to be making verbal cues because I'm trying to talk off the top of my head. I'm admittedly not an expert in this platform. I don't really claim to be an expert in really anything we have here. There's lots of experts. You know, I'm a manager, I'm a generalist, I'm an enabler, I'm a jack of all trades. I'm the orchestra conductor, right? I mean, I rely on the woodwinds to know how to play the woodwinds, right? That's not my job. But I'm happy to talk about it as best I can and encourage anybody who's interested to dive more deeply into it, because honest to God, it is a deep, deep, deep dive, right? So with that having been said, so the D-21 here was originally meant to be carried between the vertical stabilizers on the airplane. And if you look up, you can see pictures of the drone carrier configuration with a fairly tall mounting pillar in there. So the D-21 mounted in there, and when in that configuration, it was referred to as mother and daughter. That's, you know, so officially the designation was drone, but the M designation on the SR and the D on here was basically a mother and daughter nod, right? So they were working together to achieve their mission. So the mission of the D-21 as conceived was going to be an unmanned high-speed reconnaissance drone that would be released from the carrier and sent on a pre-programmed path over hostile territory to use its camera package to do photographic reconnaissance. The actual airframe itself was expendable. Once it had theoretically completed its mission, it would fly to a pre-programmed set of coordinates. The bottom side of the aircraft, it would jettison what was affectionately called the hatch, which is the whole telemetry and photographic package. It was intended to drop from the platform. The D-21 itself would self-destruct or auto-destruct. The hatch package would drop by parachute, and if it worked out, a C-130 with a special hook configuration would do an aerial recovery. Basically, I don't know if you've ever seen the old James Bond movie, I forget the movie, but they're doing the sort of the sky hook extraction with the B-17 and the guy on the ground. Same concept, right? So the parachute would be dropping our telemetry package. The Hercules would fly through with a great big long trailing hook. It would snag the parachute, they'd snatch it up, they'd reel it up on board the ramp of the Hercules, take it back for photo processing and interpret the intel it had gathered. That's ideally what it was supposed to do. However, I think, suffering from memory here, I think there are only 2 successful complete recoveries of the information. And when you read some of the history, I mean, it's almost comical, some of the mishaps they had, right? A good example is the hatch package was also waterproof and floated, right? So if the Herc missed it or if the parachute didn't deploy, it had a pinger on board, so Navy assets could theoretically retrieve the airplane or the telemetry package, right? So This actually happened once. The Herc missed one of the packages. They dropped it. It was in the water. The destroyer that picked up the signal that was homing in to pick up the package actually ran over the hatch in the water and destroyed it and sunk it. So none of it was recovered. The program was the design started in 1962, and it was a CIA, Air Force, Kelly Johnson Skunk Works project. These are very lofty ambitions. Like, you got to remember, like, people like to talk about the SR. It's designed with a slide ruler, made really before computers with like real significant number crunching capacity, so you couldn't model any of this stuff. It's a real testament to their design, and it's made out of the same titanium alloys. It's sort of an identical package altogether. The the engine is basically the same engine as a Marchand Systems. I forget the exact designation of the engine, but it was the same engine as used on the Beaumark missile, right? So, but the design on this one is it was better for sustained flight, right? So the Beaumark was a fast sprint, it was a missile launch, but this was re-engineered to give almost 90 minutes of flying time to perform the flight profile that they were trying to reconnoiter. So publicly, it's acknowledged that the D-21 performed 4 operational missions between December 1969 and March of 1971. They were all missions over the People's Republic of China, and the primary goal was to generate intelligence on the Chinese nuclear weapons testing program being performed at the Lop North site. So the record shows that the first flight was successfully launched, penetrated Chinese airspace, remained undetected by the Chinese, but lost its, for whatever reason, it failed to follow its mission profile and flew straight over China and crashed in Siberia. In the late 80s, it came out through Glasnost that the Russians had successfully captured the components and evaluated it and sort of built up their own copycat design that they had called the Raven in Russian. I can't remember the words, but they eventually they decided not to pursue that any further. The second mission over China, it completed its photography mission, got back over the recovery area, dropped the hatch, the parachute didn't open, and the camera package just disappeared in the ocean. The third mission was the one I mentioned before, where the destroyer ran over top of it and destroyed it. The fourth mission was also a failure. The aircraft penetrated Chinese airspace, overflew Nop Nor, but then had problems in flight and crashed in Yunnan. It was recovered by the Chinese and was on display at the Chinese Aviation Museum until at least 2010, when it was moved into storage. It may be back on display, not sure. So after a sequence of embarrassing failures, the program was basically retired. They went into storage here in Tucson, Arizona between 1974 and 1976 at what's now known as AMARG. By the early 1990s, they were declassified and placed on display at museums around the world, or not around the world. So they were retired and they were placed on displays around the United States. There's 12 on display. Those are all the survivors from the initial production run, other than those lost in crashes, operational deployments, and other mishaps. There's a whole lot to learn about this fascinating program, and I've only just touched on some of the highlights and key elements here. Even though retrospectively people might look at it as being, a failure. I mean, after failing to be deployed here and converting this into SR-71, there was a plan to deploy them off of B-52Hs. 2 of the aircraft were converted to carry 2 under each wing. They're the ones that did the mission drops over China, not the SRs. Fortunately, even a lot of lessons and a lot of knowledge can be learned from failure too. Not everything is going to be successful. Not every success leads to success. The materials technology working, the engine technology, the camera technology, the control technology, all of these things that came out as part of this program had a very significant impact on future design of not only drones, but aircraft, surveillance systems. But ultimately, what was spelled the death knell of both of these systems in the long run was the evolution of satellite reconnaissance technology. The use of space-based reconnaissance platforms mooted the need for manned high-speed atmospheric reconnaissance flights. It's certainly valuable for mapping or tactical reconnaissance, but for strategic reconnaissance or high-risk reconnaissance, right? Like, spying on your adversary's nuclear weapons facilities in the middle of their countries, you know, it can be embarrassing. I mean, the loss of Francis Gary Powers in the U-2 was what really led to the development of both of these, right? The U.S. didn't want to suffer the humiliation of having its CIA pilots ever captured again. So, really fascinating story. It's a really fascinating time in history. It's easy for us to look back on history and point out the flaws and the failures or the presumptions that turned out to be incorrect. But those are all steps to where we are now. And, the United States remains sort of unrivaled in its electronic intelligence gathering capabilities. So what led to the abandonment of this being used as a drone carrier deployment happened on the fourth test flight on June 30th, 1966. In the previous launches of the drone from the mothership, the launch sequence is basically deploying the drone in an outside loop, which had been reasonably successful. There was some hairy moments in the first launch where the drone sort of hovered between the two vertical stabilizers for what the crew said felt like an eternity, but was really only a few seconds. But you can imagine at better than Mach 2 trying to deploy, a bullet deploying a bullet. A lot can go wrong in a hurry, and that's really what happened on July 30th, 1966. The launch wasn't done in an outside loop. It was basically done in a level flight. The drone separated. It got a little bit unstable. It collided with the mothership, sent it out of flight profile. The crew successfully ejected. The pilot, Bill Park, lived, but the launch control officer sadly lost his life when he drowned after his suit filled with water when they landed in the ocean. After that, everybody involved with the program decided that it was best to rethink how we used it. Another interesting detail of the whole SR-71 program, which was a fairly unique innovation for the time as well, also tying into sort of needs must to make the aircraft functional. The J-58 engines designed for this airplane to fly at their hypersonic speeds, they didn't perform particularly well on the ground, and they need a lot of help that was different than a conventional engine startup. So to facilitate the startup of the airplane, this bad boy was developed. It was a technique called the AG-330 engine start cart for the SR-71 program. It was designed by a couple of Lockheed Skunk Works engineers who actually had a lot of hot rod experience, right? So they selected the engine, which was originally a Buick V8 engine, and these were engines that there were two engines in the start cart, and they were joined at a transmission and had a drive belt that then engaged to this probe that's inside this canister here. So that would give you a combined horsepower of what, probably 800 horsepower, give or take. So the idea here was you need to spool the engine up on the J-58 on the SR-71 to an ignition speed of 3,200 RPM. The idle speed for the J-58 once it was started was 3,600. So what this start cart here did was brought the engine up to that 3,200 RPM, and communication between the crew running the start cart and the crew in the cockpit, they would talk back and forth, and the pilots would be monitoring their gauges. When it reached the optimal conditions for start, the crew would then eject 30 cc's of TEB, triethyl boron, which is an interesting chemical, and that's what gave the sort of characteristic green flame out the back of the airplane when it started. That was the triethyl boron burning off. And they used that because it's a really handy fluid that's flammable at any transient temperature, which means it doesn't matter how cold or how hot it is, this stuff wants to burn. So it was perfect for lighting up an SR-71. None of this was without risk. The probe under here At the top of it was a cogged flat plate with teeth about 3 inches in diameter, and it made it into a similar shaft on the J-58, just about 2 or 3 inches inside the skin of the aircraft. Um, there was no physical, like it didn't bond together, but there were three micro switches that had to connect and agree that that everything was fitting, that it was flat and level and safe to start revolutions. Um, the tolerance on those plates had about a 1/4 inch to a 1/2 inch tolerance for out of skew, because you're never going to get perfectly level ground where you're doing this. Even though they tried to level the car, the airplane would still do, slightly different things. So it had a little bit of flexibility tolerance. Um, but interestingly, so to get the J58 to its minimal operational RPMs, you were very nearly maxing out the max RPMs on this engine. So to get these two engines generating enough speed and torque to the engine to start, they would have to be running at around 4,900 RPM. The operators also had to balance the force on the spindle to between 725 newtons. Otherwise, you ran the risk of overspeed or underspeed, which would lead to overtemperature conditions on the engine, which is just a fancy way of saying it's getting too hot and it wants to burn, sort of uncontrolled. So it was a fairly delicate balance, and the synchronicity required between both crews was really important. And it's a real testament to these guys that they were able to pull it off so efficiently and effectively all the time. Although the cart was always referred to as the Buick, in the mid-70s, the engine change went to a Chevrolet LS7 454 pair, and this is the configuration we have here. Functioned pretty much identically to the earlier carts. The earlier carts had a different control panel assembly. The operators were always positioned at a 90-degree axis from the rotation of the engines on board. Because in the event that, let's say, the spindle didn't disengage in time and the J58 went up to idle speed of 3,600 RPM, that would push this thing to almost 6,000 RPM, which almost always led to the disintegration of the engine. So you didn't want to be anywhere near the plane of pistons and parts and connecting rods scattering across the runway. And you hope it doesn't go up and penetrate the airplane, which is full of hot metal and fuel. So fortunately, none of that ever happened. This system remained in effect until the early 80s, when it was supplanted again by a pneumatic system. So pneumatic means air driven, right? So you get a great big air compressor out here. Same type of idea, connecting and spinning, but instead of a gasoline hot rod engine spewing 3 feet of flames unmuffled out of its exhausts, sounding an awful lot like a NASCAR drag strip, it went to the familiar hum of a pneumatic air compressor that we all know from airports today. The reason that was done is these guys weren't really portable. If for any reason the SRs had to divert and be recovered outside of their home bases, they were really kind of stuck until this equipment could be taken to wherever they happened to be. Converting it to a pneumatic start system enabled it to be launched and recovered from any US or NATO air base that it might end up on. So good times, it's a fun thing. So we've got a tabbed shut, so I can't show you that easily, but inside is here where the drive spindle comes from. You'll see there's two sort of bicycle grip handles here. Those stayed at this level. The probe itself had a full max extraction of about 24 inches, but functionally in a fully laden SR ready to start, that was usually between 8 and 10 inches off of here, right? If for any reason once the start sequence was initiated, the spindle wasn't able to disengage, the crew had to come in here and grab the handles and shake it as aggressively as they could to sort of break the connection, right? So you can imagine that being a little bit of a stressful undertaking. On the control panel here too, you see, you've got double sets of instruments to monitor both engines. You had a series of lights, and there was an ignition sequence that would tell you if your probe was engaged in the safe position, that your start was ready. You could take the initiation. There's your tachometer here. You have your throttle, your communications gear, your engagement clutch to start everything spinning. not too different from, your typical farm tractor or hot rod, but all tied together in this really attractive package. Right, so the elapsed time, so on the Hobbs meter here, it shows this engine set ran for 230 hours and a few minutes, right? So I really honestly don't know how long this thing would be running to get an SR started, but it couldn't have been more than 10 or 15 minutes. Probably most of the time involved here is to start the sequence of ignition on the J58s. This thing had to be at operational temperatures, so the crews would have to run it up, heat it up, perform all sorts of checks, make sure it was running the way we expected it to do before you engaged it with the riskier side of the program. So probably most of this time was spent doing oil changes, tune-ups, warm-ups, and cool downs and shutdowns versus being connected to an SR. Probably of that, maybe, I don't know, maybe an hour this time over its life would have been actually connected to the airplane. I don't know. I'm sure somebody does, but it's not a lot in comparison to the elapsed time of use on the engine.
Thank you guys so much for watching. It's a little bit of a blurb about a whole lot of project, but I hope you guys enjoyed it. I wanted to make sure that the #1 pick got a little bit of time on the channel. This was one of my favorites as a kid for a long time, and I was really surprised and impressed to chance upon the sort of larval phase of it here as the drone, but as I like to call it, I'm always out here with the jokes. Thank you guys so much for watching the video, and thanks to Mr. Marchand for his time. And we'll continue with our next video in the series, and I'll see you guys next time.